last few years, Python has been the choice of many computer students and programmers. Its importance as a language for learning and creating is ever growing. According to U.S. News and USA News, of the top 10 computer science departments teach Python and introductory computer courses. Almost all the universities in USA and Europe are teaching Python in their course curriculum. In India, Python has already been introduced into IITs, IIITs, and NITs, and in a couple of universities. It will spread to all the universities in India. Thus, Python is chosen as the best introductory language and going to replace C completely. Languages like C, Pascal, and Fortran focuses on the functional aspects, while Java.NET focuses on object-oriented programming. For example, this is a program written in C. And this is a program written in Java. This is a program written in Python. All of these gives the same output, but if we observe the time and data wasted, we would immediately join the Python club. Coming to a bit of history, Python was developed by Guido van Rossum in the year 1918. The Center for Mathematics and Computer Science, managed by the Dutch government. Van Rossum was working on a project to develop system utilities in C, where he had to interact with the Bourne shell available in Unix. He felt the necessity of developing a language that would fill the gap between C and the shell. This has led to the creation of Python. Van Rossum picked the name Python for the new language from the TV show Monty Python's Flying Orcas. Python has many flavors. Here describes its varieties. CPython. CPython is the standard Python compiler implemented in C language. This is a software directly downloaded and used by programmers directly from the website, whose link is given in the description. In this, any Python program is internally converted into bytecode using C language functions. This bytecode is run on interpreter available in Python virtual machine created in C language. The advantage is that it is to execute C and C functions and programs in CPython. Jython. Jython is earlier known as JPython. This is the implementation of programming language which is designed to run on Java platform. Jython compiler first compiles the Python program into Java byte. This bytecode is executed by Java virtual machine to produce the output. Jython contains libraries which are useful for both Python and Java programmers. This can download it free from its website, whose link is also given in the description. IronPython. IronPython is another implementation of Python language for .NET framework. This is written in C language. The Python program, when compiled, give an intermediate language which runs on Common Language Runtime ICLE. Produce the output. This flavor of Python gives flexibility of using both .NET, Python libraries. IronPython can download it from its website, again given in description. PyPy. PyPy is Python implementation using Python language. Actually, PyPy, written in a language RPython which created in Python language. It is suitable for creating language interpreters. PyPy programs run very fast as there is a JIT compiler added to the PVM. This can download it by visiting the page links in description. Since the original Python uses only an interpreter in the Python virtual machine, the Python programs run slowly. To improve the speed of execution, a compiler called JIT just-in-time is introduced into the PVM of PyPy. Hence, PyPy programs run faster than those of Python. RubyPython. This is a bridge between the Ruby and Python interpreters. It encloses a Python interpreter inside Ruby applications. This flavor of Python can be downloaded from the website link in description. StacklessPython. Small tasks which should run individually are called tasklets. Tasklets run independently on CPU and can communicate with others via channels. A channel is a manager that takes care of scheduling the tasklets, controlling them and suspending them. A thread is a process which runs hundreds of such tasklets. We can create threads and tasklets in StacklessPython, which is re-implementation of original Python language. This can be downloaded from its website. PythonXY. This is pronounced as Python XY. This is the Python implementation that we get after adding scientific and engineering related packages. We can download PythonXY from its website in descriptions. Anaconda Python. When Python is redeveloped for handling large-scale data processing, predictive analytics, and scientific computing, it is called Anaconda Python. This implementation mainly focuses on large scale of data. This can be downloaded from website whose link in description. Key features of Python include simple programming language. When we read a Python program, we feel like reading English sentences. It means more clarity and less stress on the syntax of the language, hence, developing and understanding Python becomes easy to read. Python uses very few keywords. Its program uses very simple structure, so programming in Python becomes easy. Python resembles language. Most language constructs in C are available in Python, so it is easy to migrate from C to Python. Open source. There's no need to pay for Python software. Python software can freely be downloaded from www.python.org website. Its source code can be read, modified, and used as desirable by programmers. Programming languages are of two types, low-level language and high-level languages. A low-level language uses machine code instructions to develop programs. These interactions directly depend on CPU. Machine language and assembly languages are low-level languages. High-level languages use English words to develop programs. These are easy to learn and use like COBOL, PHP, Java. Python also uses English words in its programs, and hence it is called a high-level language. Dynamically typed. In Python we need not declare anything. An assignment statement binds a name to the object, and the object could be of any type. A name is assigned to an object of one type. It may later be assigned to an object of different type. This is the meaning of saying that Python is a dynamically typed language. Languages like C and Java are statically types. In these languages, the variable names and data types should be mentioned properly. Platform independent. When a Python program is compiled using a Python compiler, it generates a bytecode. Python bytecode represents a fixed set of instructions that run on all operating systems and hardware using a Python virtual machine. Anybody can run these byte instructions on any computer. Hence, Python is not dependent on any operating system like Unix, Linux, and Windows. This makes Python ideal programming language for any network or internet. Portable. When a program yields the same results on any computer in the world, then it is called portable program. Python programs give the same result on any computer as they are platform independent. Once a Python program is written, it can run on any computer system using PVM. Procedure and object-oriented. Python is a procedure-oriented as well as object-oriented language. In procedure and object-oriented languages, programs are written through functions and procedures. But in object-oriented programming, C and Pascal, the programs are built using functions and procedures. But in object-oriented languages, the programs use classes and objects. Python has a few other features. Interpreted. A program code is called source code. After writing a Python, we should compile the source code using Python compiler. Python compiler translates the Python program into an intermediate code called byte. This byte code is then executed by PVM. Inside the PVM, an interpreter converts the byte instructions into machine code so that the processor will understand and run that machine to produce results. Extensible. The programs or pieces of code written in C or C++ can be integrated into Python and executed using PVM. This is what we see in standard Python, that is, downloaded from www.python.org. There are other flavors of Python where programs from other languages can integrate it into Python. For example, Jython is useful to integrate Java code into Python programs and run on JVM. Similarly, IronPython is useful to integrate .NET programs and libraries into Python programs and run on CLR. We can insert Python programs into a C or C++ program. Several applications are already developed in Python which can integrate it into other programming languages like C, C++, Delphi, PHP, Java, and .NET. It means programmers can use these applications and their advantages in various software projects. Huge library. Python has a big library which can be used on any operating system. Like Unix, Windows, or Macintosh, programmers can develop programs very easily using the modules available in the Python library. Scripting language. A scripting language is a programming language that does not use a compiler for executing the source code. Rather, it uses an interpreter to translate the source code into machine code on the fly. Generally, scripting languages supporting tasks for a bigger application or software. For example, PHP is a scripting language that performs supporting task of taking input from an HTML page and send it to web server software. Python is considered as a scripting language as it is interpreted and it is used on the internet to other software. Database connectivity. A database represents software that stores and manipulates data. For example, Oracle is a popular database using which we can store data in the form of tables and manipulate the data. Python provides interfaces to connect its programs to all major databases like Oracle, Sybase, or MySQL. Scalable. A program would be scalable if it could move to another system or hardware and take full advantage of the new environment in terms of performance. Python programs are scalable since they can run on any platform and use the features of the new platform effectively. Batteries included. The huge library of Python contains several small applications, which are already developed and immediately available to programmers. These small packages can be used and maintained easily, thus programmers need not download separate packages applications in many cases. This will give them a head start in many projects. These libraries are called batteries. Included: frozen binaries. When a software is developed in Python, there are two ways to provide the software to end user. The first way is to provide the PIC files to the user. The user will install PVM, his computer, and run the bytecode instructions of PIC files. The other way is to provide the PIC files, PVM, along with necessary Python library. In this method, all of the PIC files, related Python library, and PVM will be converted into a single executable file so that the user can directly execute that file by double-clicking on it. In this way, converting the Python programs into true executables is called frozen binaries. But frozen binaries will have more size than that of simple PIC files, since they contain PVM and library files also. For creating frozen binaries, we need to use other-party software. For example, is a software that produces frozen binaries for Windows operating system. We can use Pinstaller for Unix or Linux. Freeze is another program from Python organization to generate frozen binaries for Unix. Python Virtual Machine PVM. We know that computers understand only machine code that comprises 1 second and 0 seconds. Since computer understands only machine code, it is imperative that we should convert any program into machine code before it is submitted to the computer for execution. For this purpose, we should take the help of a compiler. A compiler normally converts the program source code into machine code. A Python compiler does the same task, but in slightly different manner. It converts the program source code into another code, called bytecode. Each Python program statement is converted into a group of bytecode instruction. Then what is bytecode? Bytecode represents the fixed set of instructions created by Python developers, representing all types of operations. The size of each bytecode instruction is 1 byte or 8 bits, and hence these are called bytecode instruction. Python organization says that there may be newer instructions added to the existing bytecode instructions from time to time. We can find bytecode instructions in the PIC file. The role of Python Virtual Machine is to convert the bytecode instructions into machine code so that the computer can execute those machine code instructions and display the final output. To carry out this conversion, PVM is equipped with an interpreter. The interpreter converts the bytecode into machine code and sends that machine code to the computer processor for execution. Since interpreter is playing the main role, often the Python Virtual Machine is also called an interpreter. Memory management in Python. In C or C++, the programmer should allocate and deallocate memory dynamically during runtime. For example, to allocate memory, the programmer may use malloc function, and to deallocate memory, free function is used. But in Python, memory allocation and are done during runtime automatically. Programmer need not allocate memory while creating objects or deallocate when deleting the objects. Python's PVM will take care of such issues. Everything is considered as an object in Python. For example, strings are objects, functions are objects, even modules are also objects. For object, memory should allocate it. Memory manager inside the PVM memory. For objects created in a Python program, all these objects are stored on memory called heap. Heap is the memory which allocated during runtime. The heap memory on the random access memory of our computer can increase or decrease its size depending on the requirement of the program. We know that the actual memory for any program is allocated by the underlying operating system. On the top of the system, a raw memory allocator oversees whether enough memory is available to it for strong objects. On the top of the raw memory allocator, there are several object-specific allocators which operate on the name heap. These memory allocators will implement different of memory management policies, depending on the type of the objects. For example, an integer number should be stored in memory in one way and a string should store in a different way. Similarly, when we deal with tuples and dictionaries, they should store differently. These issues are taken care of by memory allocators. Garbage collectors in Python. A module represents Python that performs a specific task. Garbage collector is a module in Python that represents the garbage collector is named as GC. Garbage collector in the simplest way to maintain a count for each object regarding how many times that object is referenced. When an object is referenced twice, its reference count be 2. When an object has some count, it is being used in the program. Hence, garbage collector will not remove it from memory. When an object is found with a reference count 0, garbage collector will understand that the object is not used by program and hence it can delete it from memory. Hence, the memory allocated for that object is deallocated or freed. Garbage collector can detect reference cycles. A reference cycle is a cycle of references to the first object from last object. For example, take three objects A, B, and C. The object A refers to the object B, whereas the object B holds a reference to the object C. Now, if the object C refers to the first object A, it will form a reference cycle. Even if the objects A, B, and C are no longer used in the Python program, still the objects contain one reference to each one. Since the reference count for each object is 1, the garbage collector will not remove these objects from memory. These objects stay in the memory even after the program execution completes. To get around this, garbage collector uses a logical algorithm for detecting reference cycles and removing objects from the cycle. Garbage collector runs automatically. Python schedules garbage collector depending upon a number called threshold. This number represents the frequencies of how many times the garbage collector removed or collected the objects. When the number of allocation minus the number of deallocation is greater than the threshold number, the garbage collector will run automatically. One can know the threshold number by using the method getThreshold function of the GC module. When more and more objects are created and if the system runs out of memory, then the automatic garbage collector will not run. Instead, the Python program will throw exception when the programmer is sure that his program does not contain any reference cycles. Then automatic garbage collector is best suitable in some cases where reference cycles are found in the program. It is better to run the garbage collector manually. For thus collect method of module can used. Manual garbage collection can done in two ways, time-based and event-based. If the garbage collector is called in certain intervals of time, it is called time-based garbage collection. If the garbage collector is called on the basis of an event, for example, when the user disconnects from an application, it is called event-based garbage collection. However, running the garbage collector frequently will slow down the program. Some common differences between C and Python are: C is a procedure-oriented programming language. It does not contain features like classes, objects, inheritance, polymorphism, etc. Python is an object-oriented programming language. It does not contain features like classes, objects, inheritance, polymorphism, etc. C runs faster than Python. Python is generally slower than C. It is compulsory to declare data types in C as string, integers, arrays, etc. Data types are automatically declared. C language type discipline is static and weak. Python language type discipline is dynamic and strong. C have pointers. Python does not have pointers. C does not have exception handling facility and hence weak. Python have exception handling facility and hence they are robust. C has do while and for loops. Python has while and for loops. C has switch statements. Python does not have switch statement. Memory allocation is manual. Memory allocation is automatic. Automatic garbage collector is absent. Garbage collector is present. Supports single and multi-dimensional arrays. Supports single-dimensional arrays by default but can support multi-dimensional arrays with the help of modules like NumPy. Indentation is necessary. Indentation is necessary. We spend a lot of time for you to teach programming, so just consider clicking the red button below. More Python courses will be uploaded in the future.